Hey there, welcome back to my channel. How's it going? In this video, we'll explore the concept of conditional probability. This is the fundamental idea in probability theory that help us understand how the probability of an event can change when we have additional information. We're going to go through this definition, some key formulas, and walk through a concrete example to make sure that everything is clear. So let's consider a simple problem, a simple example. Tossing a single die. We want to find the probability that the result is the number that less than 4 under two different scenarios. The first scenario is when no additional information is given, and the second scenario when we know that the result is an odd number. To begin with, we have to understand what conditional probability is. The conditional probability is essentially the probability of an event occurring given that another event has already happened. If we have two events, A and B, the conditional probability of B given A is denoted as P of B, vertical bar A. So that essentially means that the probability of an event B given that event A has taken place. The formula for this conditional probability is essentially the probability of A and B happened simultaneously divided by probability of an event A. The interesting part here is that our probability P B given A sometimes equals to probability of B itself. It happens in cases when our event B is absolutely independent from the event A. For example, in case when we toss a coin, the occurrence of the first event A, for example, getting a tail or a head, will not affect in any way to our second event, event B. So if we just tossed a coin, it doesn't mean that tossing this coin will affect our other tosses, the future tosses. So this is a pretty good example when our P of B given A equals to P of B. But that's not always the case though. So this is why we have such a sophisticated thing like a conditional probability. That applies perfectly for dependent events, but we're going to consider them in more details in our further videos. But for now, let's just keep in mind that conditional probability of event B given A can be calculated based on this formula. The first one, if these events are dependent. So here, as I mentioned earlier, P of A intersection B is essentially the probability that both events A and B occur at the same time, or just occur, and P of A is the probability of the event A, of course. Now let's apply this to our specific die tossing example. So the first scenario, the first condition is that we're getting result less than 4 without any given additional information. So let event B be essentially the number which is less than 4. Which number it could be? It could be 1, 3, or 2. So this is essentially the event B, the subset of a sample space. The sample space here is the numbers from 1 until the 6. Now, this one includes 3 possible outcomes, and therefore the probability of this event B equals 3 over all possible outcomes of the sample space, which equals to 6. Because we have 6 members of the sample space, 6 possible outcomes, which equals 1 over 2. So in the first case, there is a 50% chance of rolling a number that's less than 4. Now let's find the probability that the result is less than 4, given that the result is an odd number. Let event A be the event of getting an odd number, which includes essentially 1, 3, and 5 from our sample space. The probability of this event equals to 3 over 6, which equals to 1 over 2. So based on our formula, we just need to find the probability of two events A and B happening simultaneously. How can we find this? We just need to find the intersection of two sets. Let's find the intersection of two sets, which equals 1 and 3. So they're basically two numbers, which at the same time less than 4 and odd numbers. So these numbers essentially satisfy both conditions, both scenarios. So it is clear that our probability of A intersection B equals 2 over 6, which equals 1 over 3. Now let's just find our probability B given A, which equals 1 over 3 divided by P of A, which is 1 over 2, and that will give us 2 over 3. So knowing that the result is an odd number increases the probability of being less than 4 from 50% to approximately 66.666 recurring 6%. So this is about 66 at 6.6 recurring percent. So that's obviously a bigger chance that getting just a number which is less than 4, because we have the added knowledge. So conditional probability allows us to update our predictions based on new information. In our specific example, knowing that the die roll resulted in an odd number changed the probability of the outcomes being less than 4. This concept is crucial in many areas, including statistics, machine learning, and everyday decision making. So thank you for watching this video. If you have any questions, feel free to leave them in the comment section below. For more more technical discussions, join our Discord channel, and you can also connect with me in LinkedIn just to stay updated on future content and mathematical discussions. So as always, thank you for watching my video. See you in the next episode. Bye.